Next up, let's talk about the break and continue statements. These are special statements that we can include in our loops to add more nuanced control to the flow of those loops. First, the break statement, which is just the word break, when encountered by the Python interpreter, will exit the current loop that it's in. So as an example, here is a while loop. We initialize a variable I to 0, and we'll loop so long as I is less than 10, incrementing each time through. In this example, we've added an if statement with a break inside it. So if I is equal to 5, we will say break. The break tells our program flow to follow this arrow to the first command outside of the loop. That is to say, to exit this while loop and start with the next line immediately after. So in this case, this loop will go from 0 to 5. On the other hand, a continue statement, which is just the word continue, skips to the next iteration in our loop. In this example, when I in our loop equals the value 5, it says continue, which means go up to the top of our loop. What that means is the print statement at the bottom of that loop is going to get skipped. So when I is 1, 2, 3, and 4, those will all print out. But when I is 5, it will continue. It'll go back up to here, I will become 6, and it'll print 6. So the output of this code would be the numbers 1 through 4, skipping 5, and then the numbers 6 through 10. Now, the break and continue statements are typically used to react to special circumstances within our loop. For this reason, they're typically put inside of an if statement to check for those circumstances. For example, if you have a loop that's going through every student record in a class, but you find one that's missing some critical data, typically your program would crash because that data doesn't exist. But what you could do instead is use a continue statement to skip that record and go on to the next iteration. As another example, if you have a loop that's looking for some specific target, so you're going through an entire classroom looking for one specific person, once you find that target, you don't need to consider the rest of those options, so you can just stop. So a break statement, once you've found the target you're looking for, saves your code some time. Oftentimes, break and continue statements can be replaced using more specific loop conditions themselves to handle these cases. However, sometimes it's easier or more natural to write this code with a break or continue statement. Next up is the notion of precondition and postcondition loop. So we can classify loops in the general sense as either precondition or postcondition. It's a somewhat meaningless classification as there are also mid-condition loops, but it's important to note the difference between them. A precondition loop, which is the default for while loops, the condition happens before the loop body. So we ask this question, and if it's true, then we enter the loop and start repeating. If the condition is initially false, this means the loop body may not happen at all. A postcondition loop, on the other hand, reserves the condition for after the loop body. This means the loop body will always execute at least once. The body of the loop runs, and then we check to see if we should continue on a second or third time. In Python, this requires a break statement or a flag pattern in order to accomplish. Let's consider an example. So a new file in VS Code, we'll call this pre-post-condition loops.py. So this is a demo of precondition loops versus postcondition loops. I've already seen precondition loops, so let's print. This is the precondition loop. And in our precondition loop, it's just a basic while loop. So we'll say x equals 1, and while x is less than 10, we will print x, and then increment x. And now let's see what the equivalent postcondition loop would be. So print a couple spaces here, postcondition. Okay. So a postcondition loop starts off the same. We still need our variable, and we still need a loop. And in Python, while loops are preconditioned by default. So we'll say while, but instead of checking the actual condition of our loop, we'll just say while true. Notice this makes an infinite loop on its own, so we're going to have to do something inside the loop in order to break out of that loop later. We will print the value of x, and we'll increment the value of x by 1, just like we did in our precondition loop. But now we'll check, do we want to continue? So we're going to use the same condition, or an equivalent condition, but now it's using an if statement rather than the while loop itself. So we can say if x is greater than or equal to 10, then break. Notice the condition in this if statement is the reverse of the precondition loop. In the precondition loop, we're asking, should we continue while this is true? Whereas here we're saying, if this is true, then break. So it's necessarily asking the opposite question. Whereas before we're asking, is x less than 10? Now we're saying, is x greater than or equal to 10? Let's run the code and see what we get. So we say python pre-post-condition loops.py. Let's just make this a little bit bigger so we can see the results. And in both cases, we got the numbers 1 through 9. So in this case, both loops are doing the same thing. They're equivalent loops, but they're accomplishing it using either a precondition or a postcondition syntax. Now, the key difference between pre and post conditions is that a postcondition loop will always run at least once, whereas a precondition loop may run 0 times. So to test this, let's set our initial variable to 10. So looking at our precondition loop, x is 10, we ask, is x less than 10? That's false. That will never actually occur. In our postcondition loop, we have x equals 10, and now it says while true, which is true. So we'll enter our loop, we'll print the value of x, increment it, and then check should we continue. Running our code again. Notice in the precondition, nothing happens. In the postcondition, our code runs exactly once. Next up, let's try another practical demonstration of while loops, in this case for validating user inputs. So let's make a new file here. We'll call it whilejoke.py. And this is a demo of validating user input with while loops. So the idea here is the user is going to enter some sort of input, and our code is going to expect a specific range of possible values, right? If we ask the user a yes or no question and they say 7, we want to be able to tell the user that their value didn't make any sense to our code, and we'd like them to try again. So we saw a similar program to this before, so I'll just type in the initial steps here. So the user is some input. We'll ask them, do you want to hear a joke? And we'll prompt them to only enter a yes or no response, the letter Y or the letter N only. One way to ensure good user input is to only consider the possible options that we're looking for. So we could say, if user is equal to yes, then do something, and if, let's say, elif user equals no, then do something else. Right? If we're only looking for a yes or no answer, we can just respond to yes or no and then do nothing else in all other options. So in this case, we're going to tell them a joke. So if they say yes, we'll say print, what did the pirate say when he turned 80? I'm 80. Or perhaps it was, I'm 80. All right. And if the user doesn't want to hear a joke, then we'll say print, okay, frowny face, the end. So let's run this code, make sure what we have so far makes sense. So we'll say Python whilejoke.py. Do you want to hear a joke? I say yes, I hear my joke. If I say no, it frowns. And if I say anything else, nothing happens. So that works fine, but when the user gives us bad input, nothing happens. What we would like it to do is continue to ask the user until they give us good input. So if we want to keep asking, so long as their input is bad, we can just put it in a loop. So we'll say something like, while true, and then put everything in here. And now if they give us bad input, it'll keep asking. Now if they give us good input, it's also going to keep asking. So we're going to have to put something else in there to stop this loop when they give us good input. So good input is these two branches here when they said yes or no. And in either of those cases, we don't want to keep looping. So one way to solve this is to say break and break. So here we have an infinite loop that will keep looping until the user says yes or no. And in either of those cases, we'll end up at a break statement, which exits that infinite loop, making it no longer infinite. So this is a post-condition loop. We didn't need to check the condition before the loop, yes or no, because we didn't have any input from the user. We were guaranteed that the loop would happen at least once, which is good because we wanted to ask the user this question at least once. Let's test this out, make sure it works. So we run our code. If we said, yes, I'd like to hear a joke, I hear a joke and the code ends. If I say no, I don't hear a joke and the code ends. And if I say hello, it asks me again, would you like to hear a joke? And I say the word yes emphatically, but because that's not the letter Y or the letter N, it asks me again. And it'll keep asking until I say either yes or no. Now we solved this using a post-condition loop. We could, if we want, solve this problem using a precondition loop. So I'll call this using post-condition. I will comment out all this. And we'll try again using a precondition. So I'm going to put our code in here. So with a precondition, we want to change this loop to check the condition of repetition every time through. And it has to happen before we've prompted the user with anything. What that means is this user variable needs to be initialized before our loop. So we'll just give it some blank value, an empty string. Now in our loop, we can ask, does this user input have any of the valid conditions that we want? If it doesn't, then we'll continue. Now in our condition here, we can ask whether or not we should continue with this loop. In the first case, we always want to continue with the loop, right? When the user is empty, we want to continue with the loop. When the user says anything that isn't y or n, we want to continue with the loop. Now there's effectively an infinite number of possible options the user could say to incorrectly answer this question, which would mean we want to repeat the loop and ask them again. So we can't put in the condition all the possible options that would cause us to repeat the loop, but we can say those conditions that would cause us to stop the loop and negate them. So the conditions in which we want to stop the loop are when the user is equal to yes, or the user is equal to no. But recall the while loop is asking when we want to continue, not when we want to stop. So this is the opposite of what we're looking for, so we can say not that. In all situations that are not the user saying yes or the user saying no, then we want this to be true, so continue. Now we no longer need our break statements, because our precondition loop will control that for us. Try again, make sure our code works. Do you want to hear a joke? If I say yes, I hear a joke and it ends. If I say no, and it ends. And if I say anything else, the code continues. All right. So two different ways of solving the same problem. One might be more natural than the other, but it's a good idea to understand both so that you can use them in situations where you might find yourself needing them. Next, returning to our rock, paper, scissors example from the previous chapter, the code so far plays a single round of the game rock, paper, scissors. Now we'd like to extend that game so that it can play multiple rounds until the user types stop. I encourage you to pause the video and try this out, and then we'll solve it together. So in order to add repetition to our program, we need to add a loop. Now in this case, our whole game, pretty much all of the code we've written so far, corresponds to a single round of rock, paper, scissors, and we want to repeat multiple rounds. So we're just going to take all of the code and put it inside a loop. So we'll say while true, it's a generic loop for now, we can change it later if we need. And we'll take all the code and indent it inside. So now that means repeat all of this code forever. There's no way to stop playing the game effectively. So looking at this code, the way we'd want to stop is have the user inputting. So the user's inputting rock, paper, or scissors. We can give them the option to say rock, paper, scissors, or stop. And if the user says stop, then we won't do any of the gameplay. Now this is straightforward given what we've learned so far, so let's add in another option here. Rock, paper, scissors, shoot, or stop. And now we don't want to tell the user what the CPU threw. We don't want to start the next round if the user has said stop. So the very next thing we'll do is say, if the user has said stop, then we will stop. So in this case, we want to exit this loop. So we're in an infinite loop here. So we'll just say break, and now we'll exit the loop. And we'll say down here at the bottom, print, thank you for playing. And that's it. I think it's just that easy. Now this is a mid-condition loop because we're inside the loop. We have our condition to exit in the middle of the loop body. So we have a bunch of code, a bunch of other code, and in between those, the condition to exit. So let's try this out. We can run our code, python rps.py. And it says rock, paper, scissors, or stop. So I'm going to say trusty old rock. Computer recognizes that rock is the winning hand, so it continues to play it as well. And there it goes. It finally caved, and trusty old rock wins out. Now, what we can do is stop, and the game stops playing. So we have as many rounds as we want to play, and then the game ends. Now, I invite you to take this demo and continue to modify it. So one thing you could add is a score counter, so that every time you win, the score goes up. Every time you lose, the score goes down. And when you finally stop, you tell the user their total score. You could also add a lives counter so the game keeps running until they've lost 5 times, and then you count the number of times that they've played the game. Or you could also add in input checking to make sure the user only enters the values rock, paper, scissors, or stop, and in all other cases prompts them for more information.